Given this question, change in potential energy of a body, and the body is moving above the Earth's surface. This is the question, huh?
Yes,
So
sir.
tell me, yeah, what is the doubt?
The formula, sir. Do I have to use the GM1 M2 by R or just the normal GM by R?
Mm, Normal GM.
The G capital M small m by R.
Okay. So means just tell me again what is your doubt.
Like I'm not sure the formula to use.
Okay. Okay. So in this question, na, actually, just a minute. What is it? So hmm, in this question, hmm, so see this question. In this question, na, what is the question? First, you should read the question. Find change in the potential energy of mass. Find change in potential energy of mass. This is the mass when it is taken from the surface of the earth from here to here. Okay. So what I told you about the gravitational potential energy, formula for the gravitational potential energy, you can check your notes. Okay. Whenever you are getting any confusion, you should check your notes first. So here is the gravitational potential energy. So gravitational potential energy between two masses, gravitational potential energy is this U is equal to minus g m1 m2 divided by r. So this formula you have to use. This is gravitational potential energy. This formula you have to use, minus g m1 m2 divided by r. Now getting
Yeah.
this formula you have to use. Okay, so this is very easy question. We will solve it later. So question number one is this: Hmm. So this is the question. Question number 4. So in this question, it is given that figure is given, figure 8.5. So this figure is given in this question. So now we will read it. Figure 8.55 illustrates the apparatus used by Cavendish in 1798 to find a value of gravitational constant G. Okay. In a school, basically before that, I want to tell you that Henry Cavendish was a scientist. He just wait. Okay. So Henry Cavendish was a British scientist. Uh, he had done one of the experiment to find the value of G. Basically, this is given here. Okay. So after that, in a school experiment using similar apparatus means the apparatus which was used by the Henry Cavendish. Now, what is the apparatus? Two lead spheres, two lead spheres are attached to a light horizontal beam. So this is a light horizontal beam, and these are the lead spheres. When a flask of mercury is brought close to each sphere, now what is these are the lead sphere. So here, okay, you can say this is a mercury, okay, and here a mercury flask is there, like this. So make this in the spherical shape, like this. Two mercury flasks. When a flask of mercury is brought close to each sphere, the gravitational attraction causes the beam to twist through a small angle. So what will happen? What will happen? This mercury is near this lead wall, and mercury is also having a mass, and this sphere is also having a mass. So in between them there is a force of gravitation. So you can say that this there will be a force of gravitation F. And on this Mercury also, on this Mercury ball, the force of gravitation will be in this direction. Basically, this is the whole experiment. Uh, you will you can see that on YouTube. Okay, so I am not going in the experiment. We have to solve this question. I am just giving you the little idea. So when a flask of mercury is brought close to each sphere, the gravitation attraction causes the beam to twist through a small angle. So what will happen? It is like this. These are the two spheres. One sphere is here and one sphere is here. These are attached. These spheres are attached here. Okay. So these spheres are attached. So when what will happen? When one sphere from here, one sphere from here, and these two spheres are attached with a beam. Now a mercury on this side, means this side, there is a mercury flask, and on this side there is a mercury flask. So what will happen? There will be a force of attraction on this sphere, this side, and there will be a force of attraction on this sphere, this side, this side. Okay, so due to that, this beam will twist a little bit or bend a little bit. This beam will bend a little bit. Okay, and when this beam will be bended, so these are the there will be the twist in the wire. Okay, a wire is connected. Okay, you can see here, this, in this there will be a twist. Okay, from here. So now twist through a small angle. Basically, this is the case. Talking about this, this is like this. In simple diagram, this is a wire and this is a horizontal beam, and two lead spheres are there. Okay, two lead spheres are there, and there will be a gravitational force on these lead spheres due to the mercury spheres. Like this. So they will bend like this. So the next, it will look something like it will look something like this. Okay? Something like this. Now lead sphere will be here finally, and this lead sphere will be here finally. So an angle theta. So they, when they will get twisted na, like this or like this, they will be rotated like this. Both these pairs will be rotated like this. So there will be a twist produced in this wire. There will be a twist produced in this wire, and with the help of that, that twist basically is given by torque per unit twist in the wire and theta, and this is equal to the torque due to the gravitational force, and length will be given of this beam. L is the length of this beam will be given, so you can calculate that. It will become up G into m1 m2 divided by L square multiplied by, this is force, gravitational force, into length of the rod L. So force into length. So with the help of this, you can get the value of G. So from when a flask of mercury is brought close to each sphere, the gravitational attraction causes the beam to twist through a small angle. From measurements of twisting, from measurement of twisting or torsional oscillation of beam, basically this beam will be rotated like this. I have shown here. The value, a value can be found for the force producing, a measured deflection. Okay, so with the help of that, you can find the value of G, or also you can find, you can find this force also. Okay, This force also you can find. If value of G is given, then you can find the value of force. Okay, if force is given, then you can find the value of G. So producing a measured deflection. So this deflection we can measure. Okay. Basically, this deflection is measured by using a laser and all that. So I'm not going in that. G can G can then be calculated if the large and small masses are known. If it is known, large mercury masses will be large masses and these masses will be small masses. Okay. These lead masses are the small masses and mercury masses are large masses. So with the help of this setup, we can find the value of G. We can find the value of G. G can be calculated. Now, this is about the setup. Now, question number 1. This is very easy question. If I want, then I can finish this question in 1 minute. But I have to tell you the whole thing, what is happening. So now, in such an experiment, means in this experiment, one lead sphere has a mass of 6.22 into 10 to the power 3 kg. So this lead sphere means this lead sphere is having a mass of 6.22 into 10 to the power 10 to the power minus 3 kg. So this is lead sphere. This is having a mass of 6.22 into 10 to the power minus 3 kg. A small mass is there. And the mass of the mercury flask is 0.73 kg. So now this mercury mass will be is given as the 0.713 kg. So there will be certain distance between this mass and this mercury mass. Suppose this distance is d. Okay. So basically they are asking calculate the force between means between the lead mass and between the mercury. Basically this is the lead mass. Lead mass. So we have to find the value of this force. We have to find the value of this force, and this distance d is given. This distance d is given as 72 mm. So this distance d is given as 72 mm. So we can find it easily now. So this is a lead mass, and here is a mercury mass. This is mercury. Suppose this is M1 and this is mercury mass is M2. This is given as 0.713 kg and separated by 72. So this is R. R means this distance. Okay. This is given as 72 mm. Now we have to find the gravitational force. We have to find the gravitational force between them. So both will attract each other with force F. So you can find this force. So what is the formula for the gravitational force between the two masses, Shafruddin?
Gm by r square.
G.
Gm
by
r square.
G into M1 M2 divided by R square. G into M1 M2 divided by R square. Now,
are you able to hear my voice or no?
Yeah.
Okay.
So understanding means I'm using this Newton's law of gravitation. I told you that this is Newton's law of gravitation. F is equal to g m1 m2 divided by r square. First topic. So now value of g is given in the question 6.67 into 10 to the power minus 11. 6.67 into 10 to the power minus 11. M1 is this mass 6.22 into 10 to the power minus 3. M2 0.713 divided by r square 72 mm. So you can convert 72 mm into meter. 72 into 10 to the power minus 3 and square of this. Now you can solve this. This is 10 to the power minus 11 and 10 to the power minus 3. So it will become 10 to the power minus 14. Okay. So 10 to the power minus 14 is here, and here we will have 10 to the power minus 6. So here we will have 6.67 into 6.22 into 0.713 into 10 to the power uh, minus 14. Here you will have 10 to the power minus 14, and in denominator you will have 10 to the power minus 6. So this will go in the numerator. It will become plus 10 to the power minus 6. So minus 14 plus 6 is equal to plus 8. So 10 to the power 8 it will be. 10 to the power 8 it will be, na? Oh, so I do have minus 8, sorry. It will be 10 to the power minus 8. So this will be 72 square. So now, Shafruddin, please do this calculation by your calculator.
So it's 5.706 multiplied by 10 to the
Hmm.
power of negative 11.
5.7
7 times 10 to the power of
uh,
negative 11.
10 to the power minus
11
11. And what is the unit of force?
Newton.
Newton. Newton. So now you can see this is very small force, means it will be 0 point, after that 10 0, and after that 5. Negligible force, na? Very small force. So basically first answer we have completed the first part. A part we have completed. We have completed this part. We have calculated the force between them. Answer B, comment on the size of force. Size of force means magnitude of the force. So you will say the force will be very small. The force will be very small between the two masses. So why I am saying the force is very small, because you can see the force here. This force is very small. 0.10 and after that 57. Okay. So answer B you can do by yourself. Means I told you, but theory you can write by yourself. So this is basically the very easy question. Okay. This is very easy question. But here na, there is a confusion because this diagram is given. So you may be confused with this diagram. So if you want to remove this, okay, then you can remove this. And there is no need of this, but for the interest of physics, I told you what is the Cavendish experiment. Okay. So, got it? Something?
Yes, sir. I
Hmm?
understood.
Basically, the Cavendish experiment, you can, when you will do the Google or Wikipedia, from there you will get that this is the experiment to find the force or to find the capital G. And on YouTube, there are the videos also that you can see, but I think there is no requirement of that. So now this question 6, question number 6. Okay, Azan time, so we will wait. So now read this question. This second question we are going to do. So basically, this is a lengthy question, but first you should read this question. Okay. So here is this, and Shafuddin, first read this part. Okay, what they are saying, and after that you should read this. Then we will solve this question. Okay. First read this. Okay. So have you read this?
Yes, sir.
Hello.
Yes, sir.
Okay. So their first question is define the gravitational field strength. So the gravitational field strength is basically the force on a unit mass at any the gravitational force on a unit mass at any point. At any point. So first question is very easy. Second, an isolated star, an isolated star has a radius r and mass of the star may be considered to be a point mass at the center of the star. Okay. The gravitational field strength at the surface of the star is Gs. So, for example, suppose this is the star. We are assuming the star as a circular, spherical, having the radius r and mass m, and on the surface, the value of gravitational acceleration or small g is Gs. Okay. On the surface, the value of G is Gs. Okay. On a copy figure 8.6, basically this is figure 8.6, sketch a graph to show the variation of gravitational field. On a copy of figure 8.6, sketch a graph to show the variation gravitational field strength of a star with distance from the center. You should consider the distances in the range r to 4r. So basically you have to show the variation of gravitational field strength. Okay. Oh, sorry, this is not g acceleration due to gravity. This gs is basically the gravitational field strength on surface. Gravitational field strength on surface, this is given. So basically we have to plot the graph. So what I should do now, I should take this graph, this is the graph, we will use it later. So here you can see, on surface the value is 1. Okay. So to plot now, we have to calculate the value at 2r, at 3r, and at 4r. The gravitational field we have to calculate at 2 at r we know. R means at the surface. At 2r means here. Okay. At 3r, at 4r we should know the value. So what we will do? First we know at r the gravitational field is the gravitational field, that is gs. Gs is the gravitational field, and I told you the gravitational field formula from any mass. For example, if there is any mass m having the radius r, the gravitational field strength at any point from the center, the distance is r. So at that point the gravitational field strength E is equal to g into m divided by small r square. On surface, when you will calculate, it will become gm divided by r square. So at uh, gravitational field strength on the surface is this. At r, this is the value. So now we will calculate at 2r. So at 2r means, at 2r means 2r means this question will take time. Okay, so don't worry, this is the lengthy question. This is r. 2r means not in this way. I should draw in this way. This is r, radius of the planet, and at a distance here, this distance is also r. So now this is the distance 2r. So here the value of small r will become 2r. So here you will calculate the value of acceleration, value of gravitational field at this point. So it will become gm divided by small r square. So small r square means 2r square. Shafuddin, try to understand. Basically, you will get gm divided by 4r square. 4 into r square. Now gm by r square. This value is gm by r square. This value is gm by r square on the surface of a planet. This is a planet. On this surface, on surface, the gravitational field strength will be gm divided by r square, radius of the planet square. On surface, this is the value, and this value is given as gs. So gm by r square is equal to gs. So gm by r square is equal to gs. So it will become gs divided by 4. So it will be approximately equal to 0.25 times of gs. Now we get 1 point, means at 2r distance, the value of acceleration due to gravity is the value of gravitational field is 0.25 of gs. Okay, this is the value of E. Now at 3r, means you will take a point which is at a distance of 2r, like this. This is the planet, radius r, and you will take a point which is at a distance of 3r from the center, means from the surface it will be at a 2r, and this is 1r. So small r in this case will become 3r. So when you will calculate the E value, so it will be gm divided by r square, means 3r square. So it will be gm divided by 9r square, and gm by r square is gs, so it will become gs divided by 9, and gs divided by 9, 1 by 9 is basically 0.12. 0.1111 you will get, it will be 0.12 times of gs. Now at 4r, E value you can calculate easily. Now at 4r, you will take a distance from the surface at a distance of 3r. So 3r plus r, it will become 4r. So it will become gm by 4r square. So it will become 1 by 16 time of gm by r square. So it will become g on the surface divided by 16. So 1 by 16 is basically 0.0625 of gravitational field strength on the surface. Now you have plotting points. Now you have plotting point. Plotting point means at this distance, at r distance, if the distance was r, if the distance was capital R, what is the value? Gs. If the distance is 2r, what is E value? 0.25 of gs. If the value is 3r, what is the value? At 3r, it will be 0.12. It will be 0.12 times of gs. At 4r, it will be 0.0625. 0.0625 times of gs. So with the help of these points, we can plot the graph. With the help of these points, we can plot. Shafuddin, are you getting this? Hmm?
Yeah, a bit, sir.
A bit, but you have to practice this. Okay, otherwise, because these types of question will appear in your exam. Okay. Now you can plot the graph. Basically, plotting the graph is not a very complex thing. You did it in your lower standard also. Okay, but to find the points and to understand what is happening is important. So now I am telling you, we have these points at a distance r. At a distance r, what is the value of E? This is the gravitational field distance. Now see, this is the gravitational field distance E. So you have to see at value r. At value r, what is the value? The value is this 1.0 g. You can write it as 1.0 g na gs. You can write it. So at r 1.0 g gs. So at r it will be 1.0 gs. So here we will get 1 point. Now second point, at 2r, what is the value? It will be 0.25 of gs. So at 2r it will be 0.25. This is 0.2 and 0.25 will be somewhere here. It will be approximately, you can say here. So here you will get another point. Now at 3r it will be 0.12. At 3r it will be 0.12. You will get, it will be 0.2. Here will be 0.1, 0.2. So it will be 0.1, 0.12 will be somewhere here. So it will be somewhere, you can say, it will be somewhere here. Okay. At 3r. Now at 4r it will be 0.0065. So 0.0065 will at 4r. Come at 4r. What is the value of E? 0.00625. It will be approximately here. At r, the value is 1.0 gs. At 2r, the value is at 2r the value is 0.25 of gs. At 3r, the value is 0.12 of gs. At 4r, it will be 0.052s. So I am writing the points also. Okay, if you are getting confused. So consider this as x-axis and this as y-axis. So on your y-axis, there is a gravitational field. On your x-axis, there is a distance. Okay. So this point will be x comma y na. We represent the point with x. X is r. And what is y? Y is 1.0 of gs. Now second point. R, this is 2r, comma 0.25 of gs. 0.25 of gs. Now this point 3r 0.12 of gs. 3r 0.12 of gs. Now this point is 4r. This point is 4r, comma 0.0625. So now join all these points, you will get the graph. On joining these points, we will get a graph. So basically, this graph will be like this. Actually, exactly to draw this graph is very difficult on this. It will be a rectangular hyperbola type of graph. This type of graph you will get. So with distance, the gravitational field intensity is decreasing. So from the formula also you can see it is gm divided by r square. So gm is constant, but you are changing the distance. It will be 1 by r square. So rectangular hyperbola type graph you will get. So this kind of graph you will get. Now we did the question number A. We did the question number B. Question number C we have to do now. In question number C, there are also sub parts. Question number C. There are also sub part. So in question number C, they are saying the Earth and the Moon may be considered as spheres. The Earth and this is the question number. We are solving this question. This is answer number 6 and of A and B. A you have completed. Answer number 6 of B we have completed. Now we will solve answer number 6 of C. Answer number 6 of C. Okay. So the Earth and the Moon may be considered. So we can take this picture here. So the Earth and the Moon may be considered as spheres that are isolated in space with their masses concentrated at their center. The masses of Earth and the Moon are this and this respectively. The radius of the Earth is RE, and the separation of centers of Earth and the Moon is 60 RE. RE is the radius of the Earth, okay, and the separation between their centers is 60 RE. So this figure is given. This figure is given in the question. This is given in the question. So this is Earth, this is Moon. Distance between their center 60 of RE. So they are saying that answer number C of first this is. Explain why there is a point between the Earth and the Moon at which the gravitational field strength is 0. They are saying why there will be a point between the Earth and the Moon where the gravitational strength will become 0. What is the reason of it? So the reason is that in between, the reason is, take any point here. On the left of the Earth, this is the point, suppose A point. This is the A point. So if this is a A point, now here, due to both the masses, I want to find the direction of the gravitational intensity. Direction of the gravitational intensity. So suppose this is one mass. The Earth is considered as consider Earth as 1 and Moon as 2. So at this point A, the direction of the field will be in this direction, even. I told you now, if there is a mass m, and due to that mass m, if suppose this is a point P, at this point P, the direction of the gravitational field will be towards the mass. Keep in mind this point. So due to Earth at this point A, the gravitational field, the direction of the gravitational field strength will be towards the Earth. And this is the mass, this is the Moon. So due to Moon also at this point, E2 will be in this direction. So here both E1 and E2 will be in the same direction, and they will add up. They will add up, and they will add up with on the left of the Earth. If there is a point on the left of the Earth, there is a point on the left of the Earth on line joining between the two masses. At that point, the gravitational strength can never be 0. Why? Because both fields are in the same direction. Now take another point on the right of Moon. There. Suppose this is point B. So here, when you will find the direction, so direction of E1 will be in this direction, and E2 will also be in this direction. E1 means direction of the gravitational field due to Earth, E2 direction of gravitational field due to Moon. So in at point B also, which is towards the, which is at the left of right of the moon, here also the gravitational field strength cannot be zero. Why? Why? Because both are in same direction and they will be added up. E1 plus E2. Here you, when you will find the net E, when you will find here, you will get E1 plus E2, and that cannot be equal to zero. Here also you will get E net is equal to E1 plus E2, and that cannot be equal to zero. Now take one point in between the Earth and the Moon. So I am taking the point here. Now due to Earth, the gravitational field, direction of the gravitational field will be in this direction, and due to Moon, the gravitational field strength will be in this direction, E2. Now here in between, both are in opposite direction, so they can be cancel out. They can be cancel out. Okay, and they, when they will cancel out, when E1 is equal to E2. Here E net, this is point P. Here E net is equal to 0. E net is equal to 0 when E1 is equal to E2. So that this is the reason that on the right of the Earth, or on on the left of the Earth, or on the right of the Moon, the gravitational field intensity will never be zero. It can be zero. If it will be zero, it will be in between any in between the point, in between the Earth and the Moon. There will be a point between Earth and the Moon where the gravitational intensity due to both will be zero, because they are in opposite direction. So reason is that na, this is the Earth. So when the point, this point P will be here. So here the Earth's gravitational field will be more as compared to the Moon. When you will move here, here also the Earth's gravitational field will be more as compared to Moon. When you will reach this point, the Earth gravitational field will be equal to the gravitational field by the Moon, and both are in opposite direction, so they will cancel out. That is why in between there will be a point where the gravitational field due to the Earth and the Moon will be zero. And they are also asking at what distance, at what distance, uh, suppose this distance is x, at what distance from the surface of the, from the center of the Earth, I think they are asking the second part. This is the first part now. Where is the second part? This is the second part. This is the second part. So in the second part, they are asking determine the distance in terms of RE from the center of the Earth at which the gravitational field strength is zero. So they are asking the distance between this point and the center of the Earth. Means suppose I have considered this as x. Let's suppose this is x. So this x we have to find. So we can find very easily. We will put E1 is equal to E2, and we will get the value of x. Shafaruddin, are you getting something?
Yes, yes.
So this second part, now I will solve in the next class.
Okay, so and so how about the timing on Sunday? The same, 3:30 to 4:30.
On Sunday, if you can join early, then it will be better for me. Means
Early what time, sir?
early means whatever the time you have free time.
Yeah, Sunday I'm free, so anytime is possible.
Okay, so okay, I will drop you a message, and then
Yeah.
we will do. But one thing, what you should do now. These are the questions from your book, and this is also appeared. This question, basically this question that we are doing na, already appeared in your previous exam. So I want to say that na, what you should do, at least once you should revise. At least once you should revise. Okay, you are getting confusion in getting the formulas, means how to apply the formula and all that, because that is happening because you are not revising. Okay, please revise it, then you will understand. Then you will, then an interest will be developed in you towards your subject. So
Yes,
that
sir.
is what I can say, and we have done these much of topics. So hoping that you will revise, and now we will meet in the next class, and we will solve. Basically, we did this question number one. We have completed.
Yeah.
Question number second, we will second and third we will solve in the next class. Okay, and all the question that I was taking, that is from your